Hello class, today we're going to be looking at Chapter 4, Section 2 and kind of identifying the periodic table and things on the periodic table. So here are 4 questions for today. Identify groups and periods on the periodic table. What information does the group number give you? Draw a carbon atom and draw a chlorine atom. Now carbon and chlorine I just chose as random elements to be able to practice with. You need to be able to draw atoms in general, so you could pick other atoms if you choose. Here is an example of a periodic table. We are going to color code our own periodic table and draw in and write in some things that will be important for you. You will be able to use them on tests and quizzes, so make sure that you keep that handy. You can always refer back to this one to kind of know how to color code your periodic table. You will, though this one doesn't show them, you will need to provide labels for the different colors that you use. So make sure you put a key with your periodic table. Periodic table organization is shown here. And we did do this the other day in our notes, but you do need to have an idea of what you're finding on the periodic table when you look at the periodic table. So let me see if I can get the pen going here. Seems that my mouse does not want to work. There we go. So a couple things that you'll definitely need to know is the atomic number is going to be your whole number. Sometimes it's at the top of the box and sometimes it's at the bottom of the box. So you need to understand that it's the whole number. And the atomic number will tell you the number of protons. And then we have our symbol. And then we have the mass. And this is also referenced as the mass number. And the mass number tells you number of protons plus the number of neutrons. So this is a way that we can find the number of neutrons. If you take these two numbers and subtract them, you will find the number of neutrons. Okay, so chemical symbol is just an abbreviated way to write the name of the element. The atomic number is number of protons. The mass number is protons plus neutrons. And that number is rounded. This mass number, the reason it's a decimal is it's an average of all the different isotopes. We're going to get to that word today as well. It's an average of all the number of isotopes of that particular element. So again, if we want to find the number of protons, the atomic number, this is the atom's identity. If you change the number of protons, you change the element as a whole. If you want to find the number of neutrons, you take mass number minus atomic number. And that'll tell you your number of neutrons. Okay, and as a general rule, your number of electrons will equal your number of protons in a neutral atom, meaning it has no charge. The atom as a whole has equal number of protons and electrons. When you normally draw one, they have equal numbers of protons and electrons. So our periodic table organization is by groups and periods. So the groups are vertical columns of elements, numbers 1 through 18, and the key part here with groups is that they have the same number of valence electrons. And valence electrons determine chemical properties. So if they're in the same group, they have similar chemical properties. Periods are 1 through 7. And these are the horizontal rows across the chart. And this will tell you how many energy levels get used when drawing that particular element. So if they are in period 1, they have 1 energy level. Period 2 elements have 2 energy levels. And period 3 elements have 3 energy levels, and so on. Okay, so some key words for today are ions and isotopes. Ions mean that they have lost or gained 1 or more electrons. And we're going to practice with this with worksheets, so make sure that you take time to practice these and understand them. Ions happen because they try to bond with something else. And the goal is to become happy or have 8 outer electrons. That is its goal. So if something is an ion, that means that its protons and electrons no longer equal. Its electrons are either greater than or less than the number of protons at this point. There's two types of ions. You can have a cation, which is positive, and what that means is it has lost an electron. If you lose a negative, so if we had number of protons equal to 6 and number of electrons equal to 6, if it lost an electron, so now we have 5, the entire atom is now positive because it has one extra proton. Anions are negative ions, and that means it gained an electron. So if instead of losing an electron, we gain an electron, then we now have a negative charge because we have one extra electron. Our other term for today is isotopes. And isotopes are an atom that have a different number of neutrons than is normal. And isotopes are usually radioactive. Now, normal, if we look at that, is what is on the periodic table. So normally, an atom the number of neutrons will be calculated by taking mass number minus atomic number, and you get your number of neutrons. But if our number of neutrons don't match what you would find on the periodic table, then it is an isotope. And every element has isotopes of itself, meaning it has different number of neutrons. Some are heavier, some are lighter than the normal. And an example here is hydrogen has 3 isotopes, protium, deuterium, and tritium. You don't have to know those. This is just showing you an example. And this is what they would look like. We have a light hydrogen that has no electrons. We have a heavier hydrogen, which has 1 neutron. And we have triple weight hydrogen, which has 2 neutrons. The same thing happens with carbon. We have carbon 12, which is normal, carbon 13, which is not normal, but it's still stable, and carbon 14, which is radioactive. You can see the number of neutrons has changed. Note here the number of protons has stayed the same because in order for carbon to be carbon, it has to have 6 protons. And you can see that it stays at 6 protons each time. That is its identity.